Hello class, I hope you're having a good week in the snow. I'm going to go over some common mistakes when writing the rough draft. So the better rough draft, the better final draft, so try your hardest on the rough draft to improve before you submit it. And we're going to go over some common mistakes. So for the introduction, most of your sentences need to be cited, and without them, it counts as plagiarism, and you need to cite original sources. So if you were quoting or defining the optimal foraging theory, you would need to cite the original source that came up with the optimal foraging theory. Your second paragraph needs to be entirely on the independent variable, and you need to tell us what we know about ants in respect to the independent variable. A common mistake is also missing a phrase that's like, this study is important because, which is just signifying why you think the study was done and what it does for the community. Just what is it for? How important is it? And then another common mistake is differentiating between a hypothesis and a prediction. So you need to know the difference between them, which was taught in the past classes. If you don't remember, please go back. Or you can always ask your group mates. And then don't base it on the results. So depending on which class you're in, we got different results. But your hypothesis and or prediction needs to be based solely on what you thought before you ran the experiment and ran the results. Don't base it solely on what you got as a result. So, for instance, if your class got only a significant result in one data point, don't just mention that one data point in the hypothesis and predictions. You need to mention all three concentrations. And it's okay to get a wrong hypothesis or prediction. That's what science is for. As a methods, do not describe what you did individually or as groups. So quotation marks here is each person gave 6 note cards and placed 6 patches, or the class was given instructions. We're not writing this as a lab report. We're writing this as a scientific article. So describe what the entire class did, how many replicates were there. Don't mention students or each person, just say researchers, stuff like that. You need to start with a broad overview and then get into details. And don't miss any details, so we need the number of people in the class times 2, which is the number of replicates. You need to have vegetation or location. And then please don't miss the data transformation, which is your log transformation, and any other things you need in your statistical analysis. So you don't need to tell us specifically, like, you enter data in Excel, then went into SPSS, but just tell us you made this type of calculations, you use this data transformation, you use this graph to show your data, stuff like that. So for your results, you need to also start broad, so paint a picture of what the results of the study look like. So were there lots of ants, what types of ants, what insects were there, how did ants change over time, stuff like that. You also need to include your test statistics, so your F value, your P value, and your degrees of freedom. You need to not interpret your results in the results section. So that's for the discussion section. So in the results section, don't say anything about ants had a preference towards this, or and like our hypothesis was correct because of this. That's all interpreting results. And then remember that figure titles and captions go below figures, and table titles and captions go on top of the table. So in your discussion section, often people miss or very vaguely go over the future directions and broader implications. This needs to be included in the discussion section. Do not put this in a conclusion, because that's not where it belongs. It belongs in discussion, and your rough draft can include at a conclusion, but doesn't have to. Please don't miss any citations. So your discussion and your intro should have the same, like, a lot of citations within them. Those are 2 of the sections that are going to be cited a lot. And don't use incorrect conclusions about supported or unsupported hypothesis. So you need to state whether your hypothesis was supported or not, and you need to explain how the results do that and how other studies show similar results or dissimilar results. And I'll see you on Friday at my office hours. I'll be in the computer lab, so the computer lab will be open for you and your group on Friday.